Okay, so here's another example. So this time, you're not given a supply voltage. You are given a supply current and a value for R1, R2, R3 and R4. So R1's 10, R2's 60, R3's 20 and R4's 40. Now what you should notice in this one, R4 is down here, but it's not in parallel with this. It's in the current path. So if you imagine you could take that R4 and slide it round, and if you could stretch that wire out, it would be in the same line as that. So it's really R1 in series with R2 and R3 in parallel, in series with R4. So your equivalent circuit for this one would be R1, RP, and R4. That would be your equivalent circuit. Your values, 10 ohms. RP will work out again. We're doing 60 in parallel with 20. Using our same method again. $15 ohms. Gets you the value in here. R4 is 40, that stays the same. And our 2 amps is the same here. Now the same as the last time, we can work out our R total by adding R1, RP and R4. So you're going to add 10, 15 and 40. 10 plus 15 plus 40. Which gets you 65 ohms as a total resistance. And then to get our voltage for our supply voltage, so the voltage for all the circuit, you use all the current, that value there 2, times all the resistance. So it's going to be 2 times 65. Gets you 130 volts. So that now is that value there. You can also, the same as the last time, work out your voltages. So this time we'll have a V1, a VP, and a V4. So V1, I times R1, VP, I times RP, V4, I times R4. I, 2. So you've got 2 times 10. 20 volts for V1. Then for VP, 2 times 15, 30. And then for V4, 2 times 40, gets you 80 volts. And these 3 voltages should add up to give you 130. So when you add 20 plus 30 plus the 80, that's these 3 values here, you should get 130, and that should match that, which it does. So now you have your voltage here across R1, V1, 20. Your voltage across this RP, I've not left myself enough space, VP, 30. My voltage across R4, V4, 80. We can take these up here. So this 80 volts is the voltage across here, but the arrow should be the other way around, shouldn't it? We've got a voltage across here, and the other way around because it would come round the corner. Two, that's going to be your 30 volts. And the voltage here across the first one, 20 volts. They're your voltages. Now we can use that voltage to get us our branch currents I1 and I2. There are no other currents to find out because no 2 amps comes round here, flows up here, hits this junction, splits into 2 different currents. When it hits this junction here, it rejoins and it's 2 amps again. It will still be 2 amps here, all the way around here, and all the way back to the supply, still 2 amps. To get our I1, I equals V over R, so it's going to be VP. Is that voltage there, that 30 volts, over R2. So our VP over R2, so 30 divided by 60, would get you half an amp. Just check that. 30 divided by 60 gets you 0.5. And I2, VP over R3. So 30 divided by 20 gets you 3 over 2, 1.5. And we know that when we add these two values here, this value and this value, we should get this 2 amps. So 0.5 plus 1.5. That gets you 2 amps. So we've worked out what this total voltage is. We've worked out what all our voltages are for each section in series and what our resistances are for that wee parallel section in there. And that's our 4th example finished.